All right, let's go ahead and look at the calculator allowed section for this review. Not every question requires a calculator, even though you are allowed to use one for every question. So we'll go through and talk about which ones you would definitely need one for and which ones you don't necessarily need one for. So the first one, you do not need a calculator. You do not need a calculator for. It says the graph of the function f is shown in the figure above. For which of the following values of x is f prime of x positive and increasing? So let's remember, if this is the original function, they want to know where the derivative is positive and increasing. Remember that the derivative will be positive wherever the original function is increasing because it will have positive slopes. That happens at C and E. Notice that here at D it's decreasing, therefore the derivative will be negative, and here it's decreasing, therefore the derivative will be negative. At B, the derivative does not exist, so we don't need to worry about that one at all. For the derivative to be increasing, again, the derivative to be increasing, that means that the original function should be concave up, because if the original function is concave up, then that means that the derivatives will be increasing at an increasing rate. So concave down right here at C, therefore it's not that point. Concave up right here at E. Therefore E is where the derivative will be positive and increasing. So E is the correct answer here. On this next question, it says, let f be a function that is continuous on the closed interval from 2 to 4 with f of 2 equal 10. I'll just start graphing this really quick to make sure that we're all clear. F of 2 equaling 10. 2 comma 10, and f of 4 equaling 20. Ooh, that's way up there. 4 comma 20. It says, which of the following is guaranteed by the intermediate value theorem? A, f of x equals 13 has at least one solution in the open interval from 2 to 4. So if I connect these 2 points, 2, 10, and 4 comma 20, if it's continuous, it has to be connected from one point to the next. There can't be any holes or breaks or jumps or gaps. So when it says f of x equals 13 has to have at least one solution, that's definitely a true statement. Because if this is the y value of 10 and this is the y value of 20, 13 is somewhere in the middle and probably right about there. So there has to be at least one point, I've put it in green on my graph, there has to be at least one point that equals 13 because you're going from a y value of 10 all the way up to 20. So it has to pass through all the y values in between those. So yes, that one is a true statement. Hence, why it's the answer. Let's talk about why these other ones are not necessarily true. It says f of 3 equals 15. Well, it is true that at least one time it has to go through 15, but it's not true that it has to happen at 3. So just because I drew it as a straight line, which probably means mine does go through f of 3 equals 15, doesn't mean it has to be drawn like this. It could have been drawn like this, for example. And then maybe it equals 15 somewhere over here, closer to like 2.5 or something like that. So it's true that it has to equal 15, just not necessarily true that it has to equal 15 exactly at x equals 3. The next one says f attains a maximum on the open interval from 2 to 4. The purple one I drew, yeah, it's true, it does have a maximum, but the red one I drew does not. So it doesn't have to be true. D says f prime of x needs to equal 5, at least one solution in the open interval. This is leading towards the mean value theorem, and notice that that one actually doesn't have to be true because if I draw a graph that's not differentiable, so let's say that I connected it this way. If I draw a graph that's not differentiable, this one has a slope of like, I don't know, 4, whatever, or 6, and this one has a slope of like -3, nowhere does the derivative equal 5. And again, because it's not differentiable, it doesn't have to be true. If it also stated in the directions that it was continuous and differentiable, then D would have also had to be true, because the average rate of change from 210 to 420 is equal to 5. So for part D, go back and look at the mean value theorem if you want to know if that one was true or not. Last but not least, part E, f prime of x is greater than 0 for all x in the open interval. So again, the derivative is positive, and that's not true because up here, the way I've drawn this piece, the derivative is negative, therefore it doesn't have to be positive the whole time. So A is the only one that has to be true. For this one, we definitely do need a calculator, so let me get my calculator all set up. I'm going to go ahead and type this into y1, so I'll pause my screen while I do that. If you guys want to do the same, pause your screen. Alright, so here I have it in y equals, I'm looking at my question on the other slide, so you guys can't see it on your screen, but on my other screen I can see it. It says, The graph of y equals e to the tangent of x minus 2 crosses the x-axis at one point in the interval from 0 to 1. What is the slope of the graph at this point? So notice that they are restricting my x values from 0 to 1. So in my window, I'm going to restrict my x values from 0 to 1 as well. Now, it says it crosses the x-axis, so I don't necessarily need to see such a wide gap on the y-axis because I only care about where it's crossing the x-axis. So I'm going to go from -1 to 1, just because, again, I don't care what's happening really far below or above the y-axis. The x-axis. I just care what's happening right there around it. So this is what the graph looks like. And it says that it crosses it one time. The graph of y equals e to the tangent of x minus 2 crosses the x-axis at one point in the interval from 0 to 1. However, mine doesn't look like it crossed. Did I type it correct? No, I did not. That's probably my first mistake. Notice that I have e to the tangent of x minus 2 in the exponent. I'm going to have e to the tangent of x, but then I don't want minus 2 in the exponent. I want minus 2 down on the lower level. So let's try that one more time. Alright, there we go. Much better. Now my graph crosses the x-axis one time in that interval. So first thing I need to do is I need to figure out what this point is so I know where it crossed the x-axis. And then it says what is the slope of the graph. So I'm going to use my calculator to find the derivative. So first things first, I'm going to go back actually to my y equals. I'm going to put in y equals 0 because that way I can use on the graph, I can use the intersect feature. So that way I can just use the intersect feature to figure out where they cross. So second calc intersect is option 5. The first curve is this one, e to the tangent of x minus 2. So I'm going to push enter. The second curve it jumps to is this one, y equals 0. I'm going to push enter. And then it says to guess. So I'm going to scroll over here and I'm going to say, okay, that's my guess. 0.606. Now again, 0.606 is not the answer, even though it appears in the answer choices. It appears in the answer choices as answer choice A, but that is not answering the question. The question says, what is the slope of the graph at this point? So I want to know what the derivative is at 0.606. So I'm going to come back in here again to second calc, and I want to know the derivative dy dx, which is option 6. And so essentially I want to type in the derivative at 0.606, and I'm going to push enter. And they said, okay, the derivative is 2.963. 2.963. So, if I bring that back over here, 2.963 is pretty close to option D. Notice that it's different a little bit. It's not the exact same answer as option D. And the reason is because our calculators are a little bit more advanced than the calculators were when this question was written. So back in the day when this question was on the AP test, that's as accurate as they could get. But now that we're able to get more accurate, they have updated. So don't worry, on the test that you guys see in May, as well as the final exam, as well as all other tests in this class, it will be accurate according to what it should be nowadays. So this is the answer, even though it's a little different than what your calculator says. This next question we do not need a calculator for. It says the graph of f prime, which is the derivative of f, is shown above. Which of the following statements must be true? So again, this is the derivative. F has a relative minimum at x equals -3. Well, here's x equals -3, and I want to know if this is a relative minimum on the original graph. It is a 0, and it goes from negative values to positive values. So the answer is yes, this is a relative minimum. Over here at 2, this is a relative maximum, but this one is a relative minimum. So 1 is definitely true. For number 2, the graph of f has a point of inflection at x equals -2. -2 is right here. It looks like that on the graph. So remember, a point of inflection from the derivative comes from a maximum or a minimum. So I do not think that this is a point of inflection because it does not change direction. It looks like it does get flat, so maybe the derivative is equal to 0, but it does not change direction. It goes from increasing to increasing, which means it's not a point of inflection. There is one at 0, because we have a maximum there, but not here at -2. So I think 2 is not a correct answer. The third one, the graph of f is concave down for 0 to 4. All right, 0 to 4 would be from here all the way down here. Remember that concave down is wherever the first derivative is decreasing, wherever it's decreasing. So the original function will be concave up here because it's increasing, but then it reaches a maximum and it starts going down, decreasing. Therefore, yes, the original function is concave down on 0 to 4. So 3 is also true. Therefore, correct answer is answer choice E. It says water is pumped into a tank at a rate of R of T equals this equation, gallons per minute, where T is the number of minutes since the pump was turned on. If the tank contained 800 gallons of water when the pump was turned on, how much water to the nearest gallon is in the tank after 20 minutes? So I'm going to go ahead and set up an integral, and then I'm going to show you how I put it into my calculator. So first things first, if I want to know how much water is in the tank after 20 minutes, that means I need to start with how much water was in the tank to begin with, which was 800 gallons. And I need to add the amount of water that has accumulated into the tank. Notice that I'm going to use the accumulation function. So if we started at 0 minutes, and now we have 20 minutes that have passed of this function, R of T dt, if I put this into my calculator, it will tell me how much was there to begin with, 800 gallons, plus how much has accumulated in between 0 and 20 minutes of this function. That will tell me how much water is in there now. So if we come back over here to our calculators, let me put this back on your screen. We have, I'm going to type in that R of T function here. So it's 30 times 1 minus e to the power of negative 0.16 t, or x in this case. All right, that looks right to me. I'm going to go back to my main screen, and I'm going to say what is 800 plus the integral, math 9, from 0 to 20 of that y value I just plugged in. So remember, to access your variables, we go to alpha, which is the green button, and then I think F4, alpha F4, and then yeah, there's y1, push enter, and then dx. When you push enter after that, it should calculate for you how much water is in the tank. So it says 1,220 gallons of water is in the tank after 20 minutes, which is answer choice D. So let me close out of this, bring it back over here. And yes, answer choice D, 1,220 gallons. All right, and this next one. It says, if the derivative is equal to this, then f has a local maximum at. Well, we should probably graph this to make sure we understand what the derivative looks like. So, coming back to our calculator. Let's go back to our derivative, or I mean our y1. So I'm going to erase the one that was there, and let's type in this one now. So it's the square root of x to the 4th plus 1, and then outside of the square root, so notice I just pushed that right arrow to get outside of it, plus x cubed minus 3x. All right, now I need to reset my window because I still have my window set from a previous problem. So if I'm looking at the answer choices, the x values range from negative 2.3 all the way up to 1.2. So I'm going to go from negative 3 up to 2. And then I'll expand my y min, y max a little bit. So I'll go negative 5 to 5 just to see what that looks like. So here's what my graph looks like. Again, this is a graph of the derivative, and the question is asking if this is the derivative, f has a local maximum, again, a local maximum at x equals blank. Well, a maximum from the derivative will appear as a 0, which I have 3 of. Here's a 0, here's a 0, and here's a 0. It will appear as a 0 that crosses the x-axis from positive to negative. So this is going to be a maximum right here. So I just need to know that x value. Now again, I could go through and actually calculate it using my calculator, either the 0 feature or maybe even the intersect feature, but I'm going to go ahead and use my answer choices. My answer choices are negative 2.314. I don't think it's that one, because negative 2.314 is probably this one. Negative 1.132 is probably this x value right here, because notice that's a maximum on this graph. It could be 0.35, so let's try that one. I'm going to push trace. I'm going to push 0.35. Ooh, yeah, I do think that that's going to be the correct answer. Let's just try one more just to make sure. They also have 0.829. So 0.829 is this minimum down here. So I don't want that one. I want a local maximum, which is this one right here. So I'm going to go back and say that it's 0.350, which is answer choice C. Now, typically I do not encourage you to use the trace button, but remember that because we are working with a multiple choice problem and so they're giving us the answers ahead of time, I'm okay with using the trace button just to verify that what I think this is actually the correct answer. So I'm leaning towards answer C just by looking at the numbers, but using trace can help me to verify, okay, yes, answer choice C is the correct answer because it's showing me the piece of the graph that I want. On free response, never, ever, 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 ever use the trace button because you're going to estimate, like let's say they didn't give us 0.35. Let's say they gave us, let's say they didn't give us anything. It was our job to figure it out. So for example, this one, you might look at that and say that's, okay, that's -1, -2, -2.3. And you might look at that and be like, okay, it's pretty close, maybe a little bit too high, -2. I don't know, 3.5 or something. Oh, okay, that's too low. Maybe it's -2.32. I don't know. Okay, good. That looks like it's spot on. And to you guys, it does. It looks like it's spot on. But the actual point is -2.314. And until you have those exact 3 decimal places, they would mark it wrong. So again, multiple choice, it's okay to use trace because they're giving you the answers. Free response, I would never use trace because you will never get 3 decimal places, or at least it would take way too long to get there. Just use the calculator to find those zeros for you. All right, next question. Again, I would use my calculator for this one. It says, for the interval from -1.5 to 1.5, let f be the function with the first derivative given by da 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 da. Okay, so let me come back to my calculator. And I'm going to put that into my calculator. So come back here to our y equals, let's delete what's there, and let's type in that function. It says the derivative is e to the power of x to the 4th minus 2x squared plus 1. And then to get out of the exponent, push that right arrow, and then -2. Now I'm going to change my window because they want to know from -1.5 to 1.5. So I'm going to change my window from -1.5 to 1.5. And then, depending on what they want to know about it, I might change my y min and max. So let's see. It asks, if this is the first derivative, which of the following are the intervals on which the graph of f is concave down? So remember that if you're looking at the derivative, the original function will be concave down wherever the derivative is decreasing, which means I kind of do want to see a whole picture of it. So I like -5 to 5. I might even change it to -10 to 10, because I want to make sure to see a nice, clear picture of what this graph looks like. Alright, so here's my graph. Now again, if this is the first derivative, the original function will be decreasing wherever, the original function will be concave down, which is what this question is asking. The original function will be concave down wherever this function is decreasing. So it looks like it's decreasing right here, and then it starts increasing, and then it starts decreasing again right here. Alright, so there's two. Sorry, sometimes I get carried away and I don't know where my video stopped, but hopefully you guys saw the explanation for that. Let me just re-explain it really quick. I don't know how much of it you saw and how much of it you didn't. But for this question, again, we graphed this derivative. If they want to know where the original function is concave down, I'm looking for where the derivative is decreasing, which is right here on this interval from -1.5 to -1, and then decreasing again here from 0 to 1. So answer choice is D. All right, on the next problem, it says the graph of the derivative is shown above. The function f has a local maximum at x equals blank. So again, if this is the derivative, then the original function has a maximum wherever it equals 0 and crosses from positive to negative. So it equals 0 here at -3, and it equals 0 here at 1, and it crosses from positive to negative here at 1. Therefore, the original function has a local maximum here at 1. Answer choice C. Next question. All right, looking at this one. All right, for this problem, we don't need a calculator either. It's just kind of evaluating based on these tables. It says if the derivative is greater than 0 for all real numbers x, and the integral from 4 to 7 of the original function is 0, is equal to 0, which of the following could be a table of values for the function f? So, there's really only two options for when an integral can equal 0. An integral can equal 0 if you're not going anywhere, but if you notice the integral limits here are from 4 to 7, which means we've traveled 3 units. If you've traveled 3 units and your integral is still 0, that must mean that you had area that canceled itself out, meaning that some of the graph was above the x-axis and some of the graph was below the x-axis, so you had some positive area and some negative area. In addition to that, if you notice that the derivative of this function is positive, that means it's always increasing. So if I'm going to draw like the most basic picture I can think of, where from 4 to 7 we have a derivative equal to 0, it probably looks something like this. It has to always be increasing. It can't go decreasing. So here's some negative area and here's some positive area, and I think that they're about the same, which means that the integral from 4 to 7 will be 0, and it does meet the qualifications that the derivative is increasing. So looking at these graphs, this first one could not be the correct answer, because if you look at the points at 4, 5, and 7, they go from -4 to -3 to 0. Sorry, I'm at school recording this. You can hear announcements every once in a while. So because of that, if it's going from -4 to -3 to 0, that means that it was always below the x-axis, and it finally got to the x-axis at 7. So that couldn't be it, because there would be no positive area. For B, it goes from -4 to -2 to 5. All right, it could be that one, because we have some positive area and some negative area, because these 2 points are below the curve and this point is above the curve, so that's a possibility. For this one, it goes from -4 to 6 to 3. Now, again, there is some positive and some negative area, but notice that it goes from -4 to 6, which is going up, but then from 6 to 3, it's going back down again. And since the first derivative is positive, it cannot be that one. Part D says 0, 0, 0. That doesn't look like it goes up or down. And if it does go up or down in between the points, it's not allowed to, because it says it has to have a first derivative greater than 0, so it's only allowed to go up. So it can't be D. And then E is wrong for the same reason that A is wrong. 0, 4, and 6 all go up, but they're all above the x-axis, which means that there is no possibility of having negative area there, and there's no way for it to cancel itself out to be 0. So B is the only one that has positive and negative area, where my y values are always increasing, which means the function was always increasing. So B is the correct answer here. This one says the graph of the second derivative is shown above. What are all the intervals on which the graph of the function f is concave down? Remember that a function will be concave down wherever its second derivative is negative. So that's in between -2 and -1, and 1 and 3. So from -2 to -1, and then from 1 to 3 would be answer choice E. This is a related rates question. We are going to need a calculator for this one. It says a person whose height is 6 feet is walking away from the base of a street light along a straight path at a rate of 4 feet per second. If I can draw the picture that's coming here, it says if the height of the street light is 15 feet, so this is 15 feet, this is a man or person, I should say, that's 6 feet tall. They are walking away from the street light, walking away from the base of the street light at a rate of 4 feet per second. So this distance right here is increasing at a rate of 4 feet per second. It says if the height of the street light is 15 feet, what is the rate at which the person's shadow is lengthening? So you guys can see, if you kind of draw from the top of the street light to the top of the person's head, I can't get it perfect here, I gotta do this. There we go. From the top of the street light to the top of the person's head, you can see that it kind of creates this shadow. So this is an unknown, and they're looking for the rate of which that unknown is increasing, or lengthening, I should say. So, if we can use similar triangles, and we can use some variables in here, we know that, let me do some erasing. If I'm going to call this length x, the shadow x, and I'm going to call this one y, I know, hopefully you're familiar with similar triangles, but similar triangles say if we have two triangles that are similar to each other, then their sides are proportional to each other. So the length of the shadow x divided by the length of this person, 6 feet, x over 6, is equal to the length of the shadow plus the distance away from the street light divided by the length of the street light, or the height of the street light. So is equal to x plus y over 15. And if I'm going to define some variables, I don't know the length of x, I don't know the length of y, I just know that dy dt is equal to 4 feet per second, since he's walking away from the streetlight at that rate. So we'll keep that in the back of our minds for later. If I'm going to find the derivative of this function, notice that I can rewrite this as 1/6 x equals 1/15 x plus 1/15 y. If I take the derivative of that, I like it written like that, by the way, because I like these as coefficients rather than fractions. So the derivative of 1/6 x is 1/6 x prime, or dx dt, I guess I'll write it like that, dx dt, equals 1/15 dx dt plus 1/15 dy dt. So notice I actually only have two variables in this problem. I'm going to go ahead and put this in my calculator since it's a calculator question. I'm going to combine my x's. So essentially I'm going to subtract 1/15 dx dt from both sides. When I do that, when I do that in my calculator, 1/6. All right, so 1/6 minus 1/15 gives me, if I wanted to keep it as a fraction, I could. It's 1/10, or I could just put it as 0.1. I guess I'll just put it as 0.1. So positive 0.1 dx dt is equal to 1/15 dy dt. And remember, now I'm going to pull back up, we actually know what dy dt is from the very beginning. We wrote that down, that dy dt is equal to 4 feet per second. So I'm going to put 1/15 times 4. So if I solve this equation for dx dt, I get that dx dt is equal to 1/15 times 4. Let me do that in my calculator now. 1/15 times 4 is equal to 0.267. And if I divide that by 0.1 from what was in front of dx dt, I get that dx dt is equal to 2.667, which is answer choice B. So the rate at which the shadow is increasing is 2.667 feet per second. All right, next question. This one says, let f be a function such that the integral from 6 to 12 of the function is equal to 10, which of the following must be true. I want you to start noticing the differences and similarities here. Notice that here we have f of 2x, and none of these have f of 2x. So I'm guessing I need to get rid of that 2x. Let's try it with a u substitution. If I set u equal to 2x, du would be equal to 2 dx. I don't need that 2 in there because there's no 2, so I'm going to move it over by doing 1/2 du is equal to dx. If I want to change my limits of integration, when x is equal to 6, u is equal to 12. When x is equal to 12, u is equal to 24. So if I actually did this substitution, I would get 1/2 times the integral from 12 to 24 of f of u, how inappropriate of them, du, is equal to 10. Because I haven't changed anything about this, I just rewrote it in terms of u, and so this integral is still equal to this integral on the left-hand side. Now notice the 1/2 in front, none of these have the 1/2. So if I want to get rid of that 1/2, I can multiply by 2 on both sides. If I multiply by 2 on the left and multiply by 2 on the right, I get that the integral from 12 to 24 of f of u du is equal to 20, which looks a lot like answer choice B. The integral from 12 to 24 of f of t dt is equal to 20. They just did t substitution instead of u substitution. But essentially noticing that when you are multiplying the inside by 2, that it's essentially expanding that area that we are looking to take the integral of. So, B, using u substitution is how we get that. Let f be a polynomial function with values of the derivative at selected values of x given in the table above. Which of the following must be true on the interval from -2 to 6? If I plot these really quick, I think we've actually done this one before in class, but we'll look at it. It was a long time ago. -2, 3, 0, 1, oops, 3, 4, 5, 7, and 6, 5. So I have points here, 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 and here. It says the graph of f is concave up. Well, if this is the derivative, the easiest way I can connect it is like this. All right? If this is the derivative, it is concave up from 0 to 5, but it's concave down from -2 to 0 and from 5 to 6 because it's decreasing. So no, A is not true. The next one, the graph of f has at least 2 points of inflection. The fact that it starts decreasing and then it has to go back to increasing again and then it has to go back to decreasing, if this is the very most basic way I could draw this graph, it has to have 2 points of inflection because it has to turn around twice. This has to be at least one of the points of inflection and this has to be at least one of the points of inflection, or at least somewhere in between them. Like I could have drawn it more, right? I could have drawn it like this. Like if I wanted to connect them that way, then there's 1, 2, 3, 4 points of inflection. But at least there has to be 2. So yes, B is correct. The third one says F is increasing. Again, if I connect it in the most basic way, then you're right. F is increasing because it's always positive. But if I come back like this and decide to connect it like that, then there are negative pieces of the graph. So it doesn't always have to be increasing. They don't give me other values in between here. F has no critical points. Again, if I connect it like that, then we have critical points right here and here. And then F has at least 2 extrema. If I decide to connect it the most basic way again, and it doesn't actually cross the x-axis, then there are no extrema because there are no critical points. So looking at all of these individually, the only one that has to be true is answer choice B, because there's no way to connect these points together without having at least 2 times that it turns around. So B is the correct answer. All right, we're going to look at a couple free response questions. And again, these free response questions are in the calculator section, so if you want to, feel free to use your calculator. The first one says, let f be the continuous function defined on the interval from -4 to 3, whose graph consisting of 3 line segments and a semicircle centered at the origin is given above. Let g be the function given by here. What I need you to understand about this is that this is the accumulation function. Remember that the relationship between f and g is that g is the original function and f is the derivative. So if you're taking the integral of a function, it puts you back at the original function. So derivative is f, g is the original function. Let me write that down. Original and derivative. So question 1 says find the values of g of 2 and g of -2. So if I plug in 2 here and -2 here, g of 2 would be the integral from 1 to 2 of f of t dt. The integral from 1 to 2 is this area right here. That's the integral from 1 to 2. So it looks like it has a base of 1 and a height of, oh my gosh, let's see. The slope here is down 1 over 2. So again, the slope of this line is down 1 over 2. So -1/2. All right, -1/2, which means this point right here is -1/2. So the area of this triangle right here is a base of 1 and a height of -1/2. So g of 2 would be -1/4 because it's a triangle. So g of 2 is 1/2 times the base times the height. So if I multiply all those together, I get -1/4. And then g of -2, I'll do it in red. G of -2 would be the integral from 1 to -2. So from 1 to -2 is all the way back here. So it's all of this area, all that red area, plus the area of this triangle. And remember that I'm reading it backwards. So that means all the negative areas are going to be positive and all the positive areas are going to be negative. Because I'm going from a +1 to a -2, that's a backwards integral. So the area here is pi r squared divided by 2. Pi r squared divided by 2 plus, or actually in this case minus, because we're reading it backwards, minus the area of this triangle. It has a base of 1 and a height of 3. Base of 1, height of 3, and it's 1/2 base times height. Remember that you do not need to simplify it on the free response. So I would leave my answer like this. I would not try to simplify that, because if you simplify that wrong, you get it marked wrong. Leave it like that for g of negative 2. You just have to label that that's what it is. You'd say g of negative 2 equals, and for this purple one, you would say g of 2 equals. Again, I highly encourage you not to simplify, because if you accidentally multiply those wrong, and instead of putting negative 1/4, you write positive 1/4, or negative 1/2 accidentally, or whatever the case may be. There are so many mistakes to be made. Don't simplify at all, ever, if you don't need to. For B, it says, for each of g prime of negative 3 and g double prime of negative 3, find the value or state that it does not exist. So, for g prime of negative 3, remember the derivative of g would be equal to the function. So this graph is g prime. So they want to know g prime of negative 3. Okay, great. Here's negative 1, negative 2, negative 3. They want to know what value this is right here. So if I look at the slope of this line, it goes from negative 4, 1 to negative 2, 3. So it goes up 2 over 2, which is a slope of 1. So this is the point, negative 3, comma, 2. So g of negative 3 is equal to 2. G double prime of negative 3. Well, if this is the first derivative, the second derivative would be the slope of this line. And the slope of this line we just said was 1, because it's up 2 over 2, or up 1 over 1. So g double prime of negative 3 would be equal to 1. Part C, find the x-coordinates of each point at which the graph of g has a horizontal tangent line. So again, if I want to know where g has a horizontal tangent line, I want to know where the derivative is equal to 0. So it's equal to 0 here at negative 1 and here at positive 1. It says for each of these points, determine whether or not g has a relative minimum, a relative maximum, or neither, and justify your answer. So if it's okay with you guys, I'm not going to write it. I'm just going to talk through it. I would write at negative 1, g of x, or g of negative 1, is a relative maximum because it equals 0 on the derivative graph. That's very important that you're stating which graph you're looking at. It equals 0 on the derivative graph and changes values from positive to negative. Therefore, relative maximum. Then you would come over here and you would say g of 1 is neither a maximum nor a minimum because even though it equals 0 on the derivative graph, making it a critical point, it is not crossing through the x-axis, which means it is neither a maximum nor a minimum. And that would be enough to answer question C. For D, it says, in the interval, find all values of x for which the graph of g has a point of inflection and explain your reasoning. Again, I'm not going to write it, I'll just talk through it. I would say the graph of g has a point of inflection at x equals negative 2, because there is a maximum, at x equals 0, because there is a minimum, and at x equals 1, because there is a maximum on the derivative graph. Anytime that there's a maximum or a minimum on the derivative graph, there will be a point of inflection on the original function. There you go. One other thing I want to make sure that you guys state very clearly is this. So I kind of pointed with arrows, which is good, but in these ones, in part like C and part D, when you guys are like talking about the derivative graph versus the original function, please make sure that you guys actually indicate that f is the derivative of g. So I know I kind of notated it here, but in your justification here for part C, I want you guys to write f of t is or equals g prime of x. So writing that tells the reader that you understand the relationship between these two functions and that you understand when you're looking at the graph of f that you're actually talking about the derivative of g. That way, if you use the words the derivative, that they know already that you're connecting the derivative to f of t. All right, and here's how you can award points for yourself based on those different things. So notice, again, here's negative, oops, too far. Here's negative 1/4 for that first one, but if you had left your answer like that, give yourself credit for it. You do not need to simplify your answers. That's worth 1 point. On the second one, again, if you don't want to simplify your answers, leave your answer like this. That's worth 1 point to get g of negative 2. On this one, the derivative was equal to 2. Second derivative was equal to 1. Notice how they show their work, by the way, to show the relationship between the derivatives. So here they show that the derivative of g is equal to f. Therefore, g prime of 3 is equal to g prime of negative 3 is equal to f of negative 3. Here they show that the second derivative of g is equal to the first derivative of f, and therefore it's equal to 1. 1 point each for those. For part C, excuse me, for horizontal tangent lines, we have them at -1 and 1. Considering those points gives you a point. So realizing that the derivative needs to equal 0 gets you a point. Finding the 2 points where it equals 0 gets you another point, and then justifying that -1 makes it a maximum and that +1 is not either a maximum or a minimum is also a point. And then part D, you get 1 point for having the correct values, -2, 0, and 1, and then another point for the explanation, the fact that the second derivative equaling the first derivative of f changes sign at each of those values. Another way of justifying that, like we talked about before, is a maximum or minimum. All right. For this question, it says, let the function f be defined by this. F of x equals the square root of 25 minus x squared. It says, find f prime of x. I don't think, this one might be in the calculator section, actually. I don't know. If it is, I think it might actually be in the non-calculator section on the actual AP test, so I will do it without a calculator. If there are pieces, though, that make it easier, it's fine for right now, but I think you might have been expected to do this without a calculator. So the derivative of f is, it's a chain rule problem, so it's the inside and the outside. The derivative of the outside is 1/2 times this inside, 25 minus x squared, to the -1/2. That's the derivative of the outside. Times the derivative of the inside would be -2x. Again, this is a free response question. I do not need to simplify in a free response question. If you simplify that and you get it wrong, that would be terrible. So please don't simplify if it doesn't ask you to explicitly do it. If you do simplify, if you want to know if your answer is correct, you should get -x over the square root of 25 minus x squared. But you do not need to simplify. All right, so keep the answer unsimplified if desired. Part B, write an equation for the line tangent to the graph of f at x equals -3. Well, if I plug -3 into this function, I get 25 minus -3 squared, which is 25 minus 9. That's 16, and the square root of 16 is 4. So my point is -3, 4. My slope would be plugging in -3 here. If I plug in -3 here, the bottom is going to give me 4, and the top is a -3. So it's 3 over 4, or 3/4. For the equation of the tangent line, it would be y minus y1 equals m times x minus x1. Again, notice that I'm going to leave it x minus 3. I'm not going to change that to x plus 3 because if you do it wrong, they have to mark you wrong. If I put minus a negative, then that's totally fine, and I don't need to worry about simplifying it. That's my correct answer. Part C says, let g be the function defined by, and then they define this piecewise function for us. It says, is g continuous at x equals -3? And use the definition of continuity to explain your answer. So, first things first, in order for it to be continuous at -3, that means the left and right-hand limits must be equal to each other. So the definition of continuity is number 1, the limit exists, number 2, the function exists, and number 3, that the limit equals what the function equals. So f of -3, we just found out was 4. So I'm going to write that. I'm going to say, okay, f of -3 equals 4. And then I'm going to plug in -3 to the second one. I'm going to say -3 plus 7 equals 4. Then using the definition of continuity, I would say the limit as x approaches -3 of g of x equals 4. So the limit exists. I would say g of -3 equals 4 because this is the one where it says x is less than or equal to -3. So if I plug in -3 here, I get 4. So yes, g of -3 is equal to 4. And last but not least, the limit as x approaches -3 of g of x is equal to g of -3. Therefore, the function is continuous. All right, and this is the 3-part definition of continuity. Last but not least, it says find the value of the integral from 0 to 5 of x radical 25 minus x squared dx. Now, Again, this is in the calculator section, so if you use the calculator to figure that out, that's fine because I put it in this section. But like I said, I don't think this this question was designed to be in the calculator section, so I'm going to do this without a calculator just to make sure you know how to do it as well. So if I can erase this really quick, I'm going to do it with u substitution. If I set u equal to 25 minus x squared, du would be equal to negative 2x dx. I don't need that negative 2, so I'm going to say negative 1/2 du is equal to x dx. If I want to change my limits of integration, when x is equal to 0, u is equal to 25. When x is equal to 5, u is equal to 0. Because if I plug in 5 here, I would get 25 minus 5 squared, which is 25 minus 25, which is 0. If I rewrite this integral, I have negative 1/2 times the integral from 25 to 0 of the square root of, of u du. The integral of that is negative 1/2. The integral of u to the 1/2 is u to the 3/2 over 3/2. And I'm evaluating from 25 to 0. Now, up until this point, I'm still not allowed to stop yet because there are still calculus pieces involved in it. As soon as I perform the fundamental theorem of calculus, I'm allowed to stop, and I do not have to simplify anymore. So I'm going to rewrite this as negative 1/2 times 0 to the 3/2 over 3 times 2. That's plugging in 0 minus 25 to the 3/2 over 3 times 2. That is a correct answer. I would leave it like that. You do not need to simplify your problems. And if you do and you do it wrong, they will mark you wrong. Look over at the wall I have in my classroom, the wall of fame that says in green, don't simplify your answers. And I guarantee you, even though you're like, oh no, I know how to do this, I know how to do this. I agree with you. All of you could figure out how to do it given the time necessary to figure out how to do it. But when you are on the AP test and you are rushed, save yourself the time of putting in all this stuff into your brain and possibly making mistakes. Don't make simple mistakes because of that. Leave your answers unsimplified. Right now, because I know some of you guys probably did simplify this and you want to know if you got it right or not, let's look at what the simplified answer is. But again, please do not simplify on the actual AP test, or my test for that matter. You can still get credit for it. This term goes to 0. 0 to the 3/2 times 2 over 3 is 0. 25 to the 3/2 is, in other words, the square root of 25 cubed. Well, the square root of 25 is 5, and 5 cubed is 125. So this is negative 1/2 times 125 times 2 over 3. 125 times 2, put it up here, 125 times 2 is equal to 250 over 3. Um, 250 over 3 doesn't simplify actually. So at this point, I can simplify the negative 1/2 with the 250. So 250 divided by 2 takes me back to 125 again. So this is negative 125 over 3. Final answer. Again though, this would have also been a final answer, and a perfectly good final answer, that if I made any mistakes along the way, it would get me marked wrong, even though this would have gotten me marked correct. So please, 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 please be careful about that. Do not simplify your answers. And again, here are the points. For the first one, to find that derivative, and again, it does not need to be simplified. You could have left it like this. You get 2 points. For the second one, to find that the slope is 3/4 and the original function is 4, you get 1 point for evaluating the slope. So finding that 3/4 was a correct answer, you get 1 point for that. And then writing the equation for the tangent line gives you another point. For part C, finding that the limit from both sides equals 4, and because of the limit equaling 4 and the function equaling 4, therefore it's continuous. So you get 1 point for each of the one-sided limits from the left and right, and you get 1 point for your answer with your explanation about why it's continuous. And last but not least, for part D, again, they did not use a calculator. You get 2 points for the correct antiderivative, which is at this point, and you get 1 point for your correct answer. Oh, see, look, they have a positive. Oh, see, I made a mistake on mine, actually. I did make a mistake that it should be a positive instead of a negative. So go back and fix your work if you're copying from me, because the negative 1/3, and then the negative from subtracting it. I forgot to account for that double negative. So go back and fix yours. Anyway, that's how you get that answer. All right, and that's the last problem on the review.